All right, so in the next section, I want to come up with sort of a general strategy for finding any angle that's on the unit circle. All right, I don't think it's a good practice to memorize the unit circle. A lot of teachers tell students to just memorize it. I just don't think that's a good practice. I think it's better if you follow kind of this procedure and figure out the angles as you need them. So this is sort of the 4-step strategy we're going to follow. It sounds more complicated than it is. Once you do a few of them, I think you'll get the hang of it. First, identify the quadrant that you're working with. Then figure out the reference angle that you want to use, and then determine whether the value of the trig function is what the value is based on the chart we had from the previous lesson, and I'll show you that in a second. And then decide on whether it's positive or negative. And we've sort of already done some of this, but I want to kind of formalize it and do a few examples. So let's start with the first question. We want to find the sine of 135 degrees. So following this procedure, let's start with the quadrant. So 135 degrees, if we draw it, we know that that would be in the second quadrant, right? This is 90 degrees up here. This is 180 over here. 135 has to be in quadrant 2. So that means the reference angle would have to be the rest of this little angle right here. So then the reference angle, so step 1, well, let's write these out. Step 1 would be the quadrant, which we just said was quadrant 2. Step 2 is the reference angle, so I'm going to do 180 minus 135. And this, if I'm working with unit circle values, this should be a very familiar angle. 45, 30 degrees, 60 degrees, pi over 4, pi over 6. Those angles we're familiar with. That's what your reference angle should be if you're working with a unit circle. Step 3, determine the value of the trig function. So what I mean by that is for the reference angle, what is the value of sine of 45 degrees? So these I do want you to have memorized, the ones in the first quadrant. So let me go back to the previous lesson and the notes, a little bit messy here. Let me go back to the top. Where's that chart? Here it is. This is the chart I was looking for. So at 45 degrees, the sine, remember that's the y value, that would be the square root of 2 over 2, and that's what we're interested in. So that means that the sine of 45 degrees we know is square root of 2 over 2. Get my pen back here. Square root of 2 over 2. Step 4 then is decide whether it's positive or negative. So if I'm in the second quadrant, would the sine value over there be positive or negative? Well, remember, sine is like your y coordinate, right? So if I'm in the second quadrant, y's would be positive, so that means this would be positive. So therefore, the sine of 135 degrees is going to be positive square root of 2 over 2. It's going to have the same value as the sine of 45 degrees. You just need to decide if it's positive or negative. That's what it all boils down to. Let's do the next one. Cosine of 4 pi over 3. So let's figure out what quadrant 4 pi over 3 is in first. So remember, this is pi right here. So if I'm at 4/3 of a pi, that's larger than 1. So this would be 1 pi here. 4/3 would put me into the third quadrant right here. A little bit smaller than 3/2 of a pi, somewhere in here. So my reference angle would be this angle right here. So here's the nice thing about reference angles when you're dealing with radians. I actually think radians are a lot easier to work with. So let me write down, we're in the third quadrant. Let's talk about the reference angle then. So the reference angle is technically, if I work out the math, it's going to be 4 pi over 3 minus pi, get a common denominator, 3 over 3, that gives me a reference angle of pi over 3. When you're working with radians on the unit circle, whatever this denominator is, that's going to be your reference angle. So if it's 4 pi over 3 is the angle, the reference angle is just going to be pi over 3. So the radians actually are going to be kind of nice to work with once you get used to them. All right, step 3 means I need to find the cosine of the reference angle pi over 3. So let me go back to my chart from the previous lesson. Cosine of pi over 3 is right here. The cosine value is right here. So that means cosine of pi over 3 is 1/2. So let's write that down. Cosine of pi over 3 is 1/2. Okay, then step 4 is decide if it's positive or negative. So I want the cosine value of 4 pi over 3. We know that it's going to be 1/2, but is it positive or negative? Well, if I'm in the third quadrant, cosine there would be negative. So this would be negative 1/2, and that's my value. Let's try the next one, cotangent of negative pi over 3. So where is that, first of all? Negative means I'm going to rotate clockwise. I only want to go 1/3 of a pi, so that's going to put me right here in the fourth quadrant, negative pi over 3. So we know we're in quadrant 4. Step 2 is the reference angle. So the reference angle, just do that kind of quick shortcut I just told you. If negative pi over 3 is the angle, the reference angle is just going to be pi over 3 since I'm dealing with unit circle values. All right, now we need to get the cotangent value. So the cotangent, sorry, let's be careful here, not cosine. Cotangent is of pi over 3, since pi over 3 is the reference angle. All right, how can we figure this out? So let's go back to the chart for a second. Pi over 3 is right here. So my cosine value is 1/2. My sine value is root 3 over 2. This is where those identities, I think, really come in handy. Or you can use the formulas we talked about earlier. Cotangent, we said earlier, was x over y. Or we can just say it's cosine over sine. Your choice, whichever way you want to think about it. So cotangent is going to be x over y, or cosine over sine, so cosine of pi over 3 over sine of pi over 3, whichever way you prefer. So according to the chart, cosine at that location was 1/2, sine was root 3 over 2. So let's write that down. So the cosine is 1/2, the sine is root 3 over 2. We're going to flip this, so I'm going to multiply by the reciprocal, 2 over root 3. So in doing that, this goes away, these 2's go away, and I'm left with 1 over the square root of 3. I'm not going to worry about rationalizing it right now, but I do need to think about whether this is positive or negative if I'm in the 4th quadrant. All right, think about what's happening in the 4th quadrant. Your x value would be positive, but your sine value would be negative. So when you divide a positive by a negative, the result is negative, right? So the cotangent of negative pi over 3 then is going to be negative 1 over the square root of 3. So we get the value from the original unit circle location, pi over 3, but the sign is negative because I'm in the 4th quadrant, and cosine and sine are opposite signs. All right, let's do a couple more here. Find sine of 300 degrees. So 300 degrees, let's figure out the quadrant for that. 300 degrees would be in quadrant 4. The reference angle would be right here. So let's write that down. We know we're in quadrant 4. The reference angle would be, how would we get this? We would do 360 minus 300, which gives me a reference angle of 60. So that means I need the sine of 60 degrees. So go back to your chart here. 60 degrees is the same location as pi over 3 if we're dealing with radians, same thing. The sine value there is root 3 over 2. So root 3 over 2 is the value that I want, and then the question is this positive or negative? Well, I'm really in the 4th quadrant. So what do we know about sine values in the 4th quadrant? Sine values are the same as the y values, so that means this would be negative radical 3 over 2. There we go. Tangent of 5 pi over 4. So what quadrant is 5 pi over 4 in? So this would be an entire pi right here. 5/4 of a pi would be another pi into the 3rd quadrant. So we're in quadrant 3. The reference angle would just be pi over 4. So then the question becomes, what is the tangent of pi over 4? So pi over 4, remember, is where sine and cosine are the same. Pi over 4 right here. Sine and cosine are both root 2 over 2. Your tangent value is y over x, or there it is, it's just 1, which should make sense. If I do root 2 over 2 divided by root 2 over 2, that should leave me with 1. So the tangent value there is 1. So then the question is this positive or negative? Well, if I'm in the 3rd quadrant, sine and cosine are both what? Sine and cosine, or x and y, whichever you prefer, are both what? They're both negative. So think about, if I have a negative divided by a negative, that would result in a positive value. So the tangent value there would be positive. Last one here, let's do secant of negative pi over 6. Negative pi over 6, just going backwards, would only go 1/6 of a pi, would just put me right there into the 4th quadrant. Negative pi over 6. So we know we're in quadrant 4. The reference angle, since this is just like an acute angle right here, the reference angle is pi over 6. I don't have to do any special calculations. So what I need is the secant of pi over 6. So how am I going to get that? Well, secant, what you got to remember is secant is the reciprocal of which function? Secant is the reciprocal of cosine, right? So if the cosine value at pi over 6 is, so here's pi over 6, the cosine value right there is root 3 over 2. I want the reciprocal of that. So let's jot that down here. Let's jot that down. Cosine of pi over 6 is root 3 over 2. So then secant is going to be the reciprocal of that, 2 over root 3. And then ask yourself, is this positive or negative? Well, cosine, if I'm in the fourth quadrant, would still be positive. So therefore, the secant, its reciprocal, would also be positive. So secant of negative pi over 6 is still positive, 2 over the square root of 3. And that's it. Okay. I'm going to skip these next few because I know the video is going to get kind of lengthy here. Let's do these in class together and we'll go over just more practice. It's all the same techniques. Try them on your own and see how you do. That's what I would like you to do. After you get done with the video, go ahead and try these as homework and see how you do. And then let's go over these in class. Last couple examples here, I just want to show you using the calculator how you would approximate some of these values. These are not unit circle values. If it's a unit circle value, we want exact answers like we had in the previous example. It's just random values somewhere on a generic circle, and it's not from the unit circle, not those special angles we talked about. We use a calculator to figure these out. So I'm just going to use the one on the computer just to show you guys. If you have a graphing calculator, I'll show you in class how to do it. Let's start with sine of 71 degrees. So the first thing you need to do, if it's in degrees, make sure your calculator is in degree mode. So on the computer, I've got these options here, degree, radian, and there's another one called gradient, which we're not going to use, but degree is the one I want. If you're using your phone, you have to do the angle first, just like you do on the calculator. So I'm going to type in 71, and then on the computer, then I'm going to put this little button that says trigonometry, and I'm just going to click on sine, and here it is. So round it, however they tell you to round it. Oops, I wish I could leave that up, but it's right here. 0.9455 is the approximate value. So these are always going to be rounded. So 0.9455. Tangent of 5 pi over 7. So to put that in the calculator, let me go back to radian mode first of all, because this is radians. So I need to figure that out. So 5, it's a little tedious on the calculator. Oops, let me clear this out. 5 times pi. Oh gosh, do I have a pi key? There it is. All right, 5 times pi. I'm going to hit equals and then divide by 7. So I've got to get a decimal approximation for that angle first. And then I want the tangent of that. So go back to your trigonometry menu and click on the button that says tangent. And then that should be it. Let's see, tangent of that angle. Yeah, negative 1.2539, it looks like, is what I'm going to go with. So negative 1.2539. The last one is secant. And what you're going to notice on your calculator is that there is no secant key. You've got sine, cosine, and actually, you know what? I lied. This calculator does have a secant key on it. I'm surprised because most calculators do not. I don't believe your phone does as well. So I'm going to have to show you in class how to do the reciprocal functions, secant, cosecant, and cotangent in your calculator in class. But what we can do, let's do it this way. So remember the identity. Secant was 1 over cosine. Let's do it. I'm gonna pretend that button's not my calculator. I'm gonna do it the way you would have to do it if that button weren't there. Secant is 1 over cosine of whatever that angle is. Remember that identity from the previous lesson. So in your calculator, you're literally going to do 1 divided by the cosine of 1.3. 1.3 is radians. There's no degree symbol, so we assume that's radians. Let me see how to do this in the calculator. I'm going to do 1 divided by, I'm going to type in 1.3, and then I'm going to go to here, and I'm going to type in cosine. I think that's what I want. So 3.7383, it looks like. So 3.7383. Just for fun, because this button did show up in my calculator, let me try doing it that way. So if I do 1.3, and then I'm going to type in the secant. Yeah, same value, 3.178. Basically, the calculator is doing that reciprocal work for me. But I don't think your phone will do that. So remind me in class to show you that example again. All right, and then the last question, number 8, we're working backwards. So make sure you're clear on the difference in this question to the previous question. This time, they want you to find the angle whose tangent value is 1.2786. They're giving you the value. They're asking you to find the angle. And what we're going to do is we're going to use something called the inverse. We'll talk more about inverse functions with these later in the chapter. But for now, what you want to remember is that, think about it this way. If I have the equation tan theta equals 1.2786, if I want to get rid of the tangent, I would take what's called the inverse tangent of both sides. Let me show you what I mean here. Go ahead and write this out. And I'll show you how to do this in a calculator. So essentially those I don't want to say cancel out, but they undo each other, and that leaves me with theta. So theta is what I'm looking for, is equal to the inverse tangent of 1.2786. You do this when you're looking for the angle. You're going to use this inverse tangent key. So let me go back to the calculator. And I think it's probably, I need to use the second. Yeah, that's what it is. These are my inverse functions in the calculator. I probably have to put the angle in, or not the angle, but the measurement in first. So that would be 1.2786. And then I'm going to do second tangent. And I believe that's it. Oh, wait a minute. Sorry, I pushed an extra button. Let me try that again. 1.2786. And by the way, they didn't specify whether this should be in radians or degrees. I'm in radian mode, so I'm going to leave it that way for now. And my answer is a radian as well. So I'm going to go second tangent, and I get 0.907. So the radian measure for this is about 0.907. If we had put this in degrees, let's try it in degrees. If I change this to degree mode, there it is, degree mode, and I do the same thing, 1.2786, and then I'm going to go, let me clear this out again, 1.2786, and then I'm going to go, so second tangent, I get about 51.97 degrees. So in degrees, that would have been about 59 point, whatever I just said, 97 degrees. So that's in the first quadrant. That looks about right. 0.907 radians would be in the first quadrant. Your choice, if they don't specify whether they want radians or degrees, which one you prefer. Okay. Okay, I think that's it for this lesson, and we will do some practice on those unit circle values tomorrow in class.